Ladies and gentlemen, thank you for joining us today for the webinar titled Lessons from Kennecott, Utah Copper's Manefay Slide, presented by Brad Ross, Mine Technical Services Manager, and Cody Sutherland, Cornerstone Operation Manager, both with Rio Tinto Kennecott, Utah Copper. My name is Tessa Baxter. I'm the Division and Local Section Coordinator here at SME, and I will be serving as the host for today's session. Our session today will consist of approximately 45 minutes of presentation by Brad and Cody, followed by a 15-minute Q&A session. All questions must be submitted in writing to the SME host using the WebEx chat or Q&A panels. If you don't see those panels on your screen, you may need to activate them. Now I'll pass control of this session over to Brad Ross to start the presentation.
Thank you, Tessa. Good morning, everyone. Hope everybody's had a good morning so far. This is going to be a little different for us today in the fact that we generally actually see the audience. So bear with us in the fact that we can't actually interact with you directly. Today, though, Cody and I are going to talk a little bit about what we've learned from the Manefay slide that happened at Kennecott, Utah Copper last April 10th. To talk a little bit about Kennecott to begin with. As most of you know, Kennecott, Utah Copper is part of Rio Tinto. The mine itself is located just outside of Salt Lake City, Utah. The mine is a major producer of copper cathode, molybdenum, gold, silver, and sulfuric acid. We're an integrated operation, in fact, that we have the mine, we have a concentrator, we have the smelter, refinery, and of course our tailings area. And as I mentioned, we're just outside of Salt Lake City, and so we also have a lot of neighbors that are very close to us. Kennecott is part of the Rio Tinto group. Rio Tinto, as most of you know, is one of the largest mining companies in the world. We have operations that span the globe in areas such as iron ore, aluminum, copper, gold, diamonds, energy, and various minerals. But what we want to talk to you about today is the Manefay and the Bingham Pit mine. So Bingham Pit is over 110 years old. It's also one of the largest open pit mines in North America. We're nearly 2.5 miles wide and 3/4 of a mile deep. On April 10th, the story about Kennecott would be basically a normal mine up until the point that the Manefay slide occurred. At that point, we were involved in basically the largest mining slide in history. The slide itself was nearly 150 million tons. It occurred in basically 2 events. One event was at about 9:30 at night, and then a second one very shortly thereafter, at just a little over 11 o'clock. The Manefay itself is called the Manefay because of the bed that it sits on. The Manefay is basically a hornfeld intrusive. And as with a lot of intrusives, there are areas of weakness both above and below the bed. Although we had done a lot of work beforehand, we had not anticipated a slide of the scale that occurred on April 10th. The other thing that we didn't anticipate was the way that the slide acted. We had done a lot of work. We had in the previous few months before the slide occurred, had actually projected and predicted that the slide was going to happen, and that it would be large. But in the earlier work, that had not come out as one of the potential issues. The one thing that we didn't predict was how it would act. We've had a lot of slides at Kennecott, dozens, maybe more. These slides range from a few thousand tons to 1 million to 1.5 million tons. And they'd always acted like a rock slide, and the fact that they happened over a period of time, maybe days or sometimes even weeks. And they basically built up and from the ground up and acted like a large slide that you could monitor over time. The Manefay acted a lot differently. It acted like an avalanche, and the fact that it happened very quickly. Although we could monitor the movement beforehand, when it did fail, it all rushed down at once. And instead of covering 10% of the pit like we expected, it actually covered nearly 95% of the pit bottom. So what did that mean for us? Well, one of the things that happened is that we knew that we would be in a situation where we would have a difficult time getting people and equipment down to the pit. So to be prepared to continue the operations, we had actually stationed spare parts and spare equipment and supplies down in the pit bottom. So this shows a picture of the pit bottom before the slide occurred. And one of the things that you may note is that in the pit bottom we have a dome, which is basically an area with lower quality ore. And in this dome, we felt that on the right side of the screen that the slide would come down, build up against the dome, and basically reach back up to where the slide had begun. That's not the way it worked. The way it worked is the slide went right over the dome because it was moving so fast and there's so much material. It covered our preparation, covered our supplies and material, and damaged a significant amount of equipment. The force of the slide was unbelievable. This is a P&H 4100 shovel. The boom of this shovel was not involved in the slide itself, so it was left undamaged. But the rest of the shovel is basically unrecognizable. We actually lost 3 shovels during this event. In addition to the shovels, the slide moved trucks around like they were little Tonka trucks. In all, we had 13 trucks that were involved in the slide. 8 of those trucks were damaged beyond repair, but we were able to repair 5 of them. This is a picture after we've had some of the trucks that have been exposed from some of the slide debris. One of the trucks we were able to repair, the other ones we were not. In addition to the pit equipment, we also had some damage to some of our other facilities. This is our Bingham shop. The Bingham shop was right on the edge of the slide, right above the scarp. Although the shop was still standing, it was severely damaged, and we had to demolish the shop, not only because of the damage, but because of the location compared to this side of the slide. As well as the damage that happened to equipment and infrastructure, the pit itself was severely damaged. We lost our 10% haul road. We only had one access into the pit for major mining equipment. The slide left major scarps that you can see up around the top edge of the slide. These scarps represented a danger for us going forward because there was a potential for more of that material sliding down all the way into the pit. We also lost a lot of our safety benches, and as most of you know, safety benches are a critical part of keeping our miners and our equipment safe. In addition, the slide covered up a major portion of our ore as well. But the one thing to remember about this slide is that although it was large in scale and caused lots of damage, no employees were hurt or killed during this event. That in itself is a major accomplishment. I got to tell you, all the employees at Rio Tinto in Kennecott really believe that it would have been a whole different situation if we were trying to recover bodies instead of just trying to bring the mine back into operation. So how did we do that? Well, one of the primary ways is because we actually have a lot of protection for our people geotechnically. We do a lot of monitoring, we do a lot of training so that people are aware of the dangers and we're looking out ahead before they actually happen. Our protection not only includes high-tech equipment, it also includes the people and everybody that works at the mine. So the first one is training everyone. Everyone that works into the mine on a day-to-day basis is trained on what to look for. They're trained to look for cracks. They're trained to look for material that's falling. They're trained to look for dust that really doesn't belong. We were able to observe several indications that there was a problem coming well before the mine had the slide in April. As a matter of fact, we also have a lot of higher tech ways to monitor the mine as well. One of them is a prism network. We have over 300 prisms and 5 skyboxes. The skyboxes is where we have robotic total stations that monitor these prisms, and they can measure very, very accurately how much movement they're seeing over time. We also have 2 different types of ground ground radars, or radars on our spine. One of them is a ground probe radar, which you can see a picture here of one of our portable systems that we can take into any part of the mine and monitor up close if we see any sort of problem. The picture actually shows the Manefay area that we're concerned about. And the higher color, or the brighter colors that you see, is areas of movement. So there was a clear indication that there was a problem going forward. We also use an IBIS radar system that sits on the far side of the pit, which in many cases can be 2.5 miles away. You can monitor a large portion of the section of the mine all at one time. With these types of systems, and this is another output of the IBIS radar system, we could detect that there was a problem going forward. The yellow areas that you see show an area of movement. The brighter the color, the more the movement is. The areas that are lighter in color are areas that it's not moving. In green, you can see the Manefay fault. And obviously, the area above the Manefay was moving faster than the area below the Manefay. With faults and with slides like this, it's really not how much movement there is, but it really depends upon if there's acceleration. We actually have areas in the mine that we can see as much movement as 12 inches a day. We're not actually concerned about a slide because it's not getting faster. The Manefay was moving much slower, tenths of an inch a day, and yet we knew back in November of 2012 that there was something different, there was something wrong. We were starting to see some acceleration. By February, the middle of February 2013, we actually had determined that there would be a failure. By the first part of March, we determined that that failure would be large. Now, we expected at that point in time that the failure would be over 100 million tons of material, making it the largest failure in mining history. As I said, the failure was nearly 150 million tons by the time it actually happened. Fairly shortly after that, we also determined that the failure would occur basically in the middle of April. The final date that it did fail was April 10th. So what did we do during that time? Communications was key. One of the things that we had built was a response plan, depending upon what we saw with the movement of the Manefay bed itself. When we were in a green status, that meant that the movement was relatively steady, and so that we basically had normal operations. We were doing a lot of work at that time, but our actual mining operations were basically unchanged. On April 5th, that status went from green to yellow, meaning that we saw more and more movement coming up, and it was starting to accelerate even more. At that point, we knew that Manefay would basically fail in a matter of days. And indeed, on April 10th, we went basically to our orange status. Orange status meant that the failure would occur within hours. And at that point, when we went to orange, we evacuated the pit and got everybody out. That night, failure occurred. We evacuated people before 11 o'clock in the morning. 9 o'clock that night, the failure occurred with the second one at a little over after 11. Other things that we did during that time to prepare is that we started looking at all the areas that would be impacted. We found that one of our major electrical lines was going to be impacted, so we had that relocated. And importantly, we also had a communication tower that was involved in the Manefay slide. And importantly, we had that tower moved and put into a safe location, because the day after the slide and from then on, communications was key, because that's actually how we monitor our pit with our geotechnical monitoring equipment. It's all done through telemetry, so the communication towers were critical. We also moved buildings. Some of you may have been at Kennecott before and visited our visitor center. That was right on the edge of the pit where the Manefay was going to fail. We moved that building as well as some others to make sure that they were out of harm's way. We also moved office buildings and other infrastructure to be prepared. When we went to yellow, as I mentioned, we actually moved 2 of our large mining shovels out of the pit bottom so that we would be prepared to start the remediation work after the slide occurred. Because we knew that we'd have to not only work from the bottom of the pit, where we'd have limited access, but we'd also work from the top of the pit, so we could move in two directions at once. When the Manefay fell, I got to tell you, it was one of the most amazing sights I've ever seen. The mine actually looks a lot different now, but the day that it happened, we were just in awe. We didn't expect it to look the way it did. And every one of us, when we saw the first pictures, were just basically quiet, trying to think, how do we go from here? Fortunately, not all was lost. There was some additional equipment in the pit that was not damaged. This picture shows the pit bottom just after the Manefay failure. This area where the cursor is pointed is actually a P&H 2800. It was the only operating shovel that we had left available in the pit. We also had 22 trucks scattered throughout the pit bottom, and you can see them in some of the different locations. In addition, we have an in-pit crusher that's still operational, with an in-pit conveyor that goes through a tunnel that then goes on to our concentrator further down the line. Also importantly, we had some ore remaining. So the shovel itself is sitting on ore, and so we had one sector of ore that we knew that we were able to start mining with. The other thing that we had, and we were prepared for before the Manefay, was what we call the Keystone Access. The Keystone is basically a one-lane light vehicle traffic road with 13 switchbacks. That was our only access to get to the pit bottom, and that's how we got both men, supplies, and parts to the bottom of the pit. And later on, we would also move mining equipment down, part by piece, so that we could build them down in the pit bottom. Just 2.5 days after the Manefay failure, Kennecott was actually back in operation at the top of the pit in the areas that had not been damaged. Unfortunately, that's not where our ore is. So, like all mines, ore is our lifeblood. We only had one shovel, that P&H 2800, our 68 shovel, and that became our primary focus, how to make that shovel as productive as we possibly could. When we started, our estimates were that we would be able to mine about 50,000 tons per day with that shovel. That was a fairly typical rate. In 2.5 weeks, we were back in operations with that shovel in the pit bottom, and in just over 3 weeks, we were up over 70,000 tons. Very quickly, we were averaging over 100,000 tons a day with just that one P&H 2800 shovel. Later on, we were able to get additional equipment down in the pit, and after the Manefay slide, up until the point that we were able to get all of our equipment down in the pit by reclaiming or remediating the 10% haul road, we averaged 120,000 tons per day of ore movement. We couldn't have done that without a lot of support from a lot of different people. New equipment was a critical part of what we needed, and we very quickly ordered new equipment so that we could get it there as fast as possible. We ordered 20 haul trucks, 38 dozers, 4 drills, 15 excavators, 3 loaders, 2 shovels, and, interestingly enough, 25 remote-controlled systems. Those remote-controlled systems were needed because we're going to be working in areas that it really wasn't safe to put people. With the help of our vendors, which is listed beside here, we were able to get a lot of that equipment in record time. Without their help and support, we really wouldn't have been as successful as we were. An example is our Hitachi 5600 shovel, hydraulic shovel. We needed additional loading capacity down in the bottom of the pit. Pretty tough to do to change that when we only have a one-lane light vehicle traffic road going down. So we did some fairly innovative things. One of the things is we took a Volvo reticulated truck and we changed it from a haul truck into a flatbed truck. You can see here the picture of that truck hauling down some of the track paths for the Hitachi shovel. Not everything could fit on that truck, however, so we also constructed a sled so that we could put the larger pieces. That sled was then pushed and pulled with two different D11 dozers to go around the tight corners of the switchbacks on the Keystone Road. We actually didn't have much area. The area that we had to work with to build this equipment was actually half the size that most manufacturers would say that we needed. But by working closely with them, we were able to optimize that, get the parts there, and have that shovel built so that by July 2nd, we were able to have the Hitachi 5600 shovel commissioned and in the dirt. We did the same sort of thing with the Komatsu haul trucks. Again, with taking it down in pieces. Even the bed, which is normally comes in one piece, was cut in half so that we could weld it back together down at the bottom of the pit. Again, you can see the dozers that would both push and pull, one basically acting as the brake, the other one to slide it around at the top. And that's how we were able to get it down that one-lane road. You can see the dozers going down that road. They just barely fit, so it was quite a task just to get the parts down. Komatsu did some amazing things for us as well. The first truck was in the dirt by July 30 or June 30th. The pit bottom, we had a truck down at the pit bottom by July 26th. And we took 4 trucks down to the pit bottom. All 20 trucks that we purchased were in operation by October 31st. The other one that was a fairly major accomplishment was our P&H shovel. We needed to replace the shovel that was destroyed that we've already showed you a picture of. And so we actually procured that shovel. We had the parts sent, and it was in production by the first part of September. And those of you that have built shovels before know that generally that's a year-long task. So we were pretty fortunate to be able to get it in such short time. It took a lot of work from a lot of different people, but we were able to make that accomplishment. So I've talked about a lot of different accomplishments. You know, there's a lot of different things that led to those. One of them is that we had a common goal. Having everybody working toward that one goal was critical for our success. Second thing is we had a committed management. Be able to order the equipment and take on those costs and those factors that quickly is something that I have not seen a management group do in the past. But they knew that if we were actually to get back into operation, we needed to act quickly. We had a tremendously motivated workforce. That workforce did things that would have normally taken us weeks and maybe months changes that we needed to make operationally. But they were willing, and not only willing, but excited about making those changes quickly. And of course, our vendor partners were a critical part as well. But with all of this work and all those accomplishments, I think the most impressive accomplishment was the remediation work. The mine had adequate ore basically to get us to the first part of 2014. If the remediation work wasn't completed by that time, the company was going to have an ore gap. I got to tell you, our first estimates for that remediation work to be completed was basically the middle of 2014, which would have given us a 6-month gap. If that gap occurred, not only was the mine impacted, but everything downstream was going to be impacted as well. The concentrator, the smelter, the refinery. So to talk about that remediation work, following is Cody Sutherland. He managed that remediation work, and he'll tell you some about what happened.
Okay. So the remediation work. Go ahead. Can you hear me?
Yeah.
Can you hear me? Okay. So for the remediation work, pretty much to start off with, just to give a little bit more background on it. When I was handed this problem, or when I was in planning, this was pretty much the problem that we were handed, and so at the time I was a mine planning superintendent and had to work with my team to develop a plan, and then later after we got a plan developed, I was handed this role of actually going and implementing the plan. So a little bit on it, 400 feet of vertical scarps. So up at the top, they were up over 400 vertical feet that we had to deal with, even down by the shop that was destroyed. That was almost 400 feet. There was remaining rock mass on the slide that posed another 20 million ton failure from the top that could come down and cascade over what had already failed. We had a truck shop that was hanging over top of a 400-foot scarp that was destroyed and had it removed. We had lost 1,500 feet of access road for our haulage that went across the slide. We had to clean more than 2,000 vertical feet of benches, and we had the bottom of the pit that was covered over 300 feet deep. So while we were in planning, we came up with a plan on how to remediate this piece by piece. We started with the headscarp design to get that to a safe configuration so that we could go below it and work. We had the intermediate scarps on the side that we had to take the scarps down. We had a scarp on the above our office buildings and right above where our 10% road would go. We had to put in a new road. We had to clean benches over on the side. We also had to mine out slide debris and eventually work our way down to where our next ore would be, which would be right here in what we call the E4 bench area. And we also had to build a road up to that. So by developing this plan, we had a really mapped out process of how we would do that. Once we had that plan, we had to decide how much equipment we needed. And Brad touched on how much equipment was delivered. But how we did that was we went through each area and said, how many dozers, how many excavators, and how many loaders and shovels would we need, and how much that needed to be remote based on the problem. So we sat down and made estimations of how much equipment we would need, and that's how we came to the numbers of what needed to be delivered in order for us to complete this project. Once we had our equipment in our plan, we had to put together a timeline, and this was really key for us. By knowing what your timeline was, we knew that. So we had to know when we knew when we had to be completed. Our goal was to be completed by the 24th of November. So we developed our timeline based off of that, and then we also tracked that. We knew every day where we were at on our remediation efforts. We knew how many days out we were. And you can see in the yellow here that there was times we were way out of schedule, but we also had times where we finished ahead of schedule. By knowing this, it allowed us to create that alignment and also have people understand where we were at. And I can tell you, in August, that was a tough time for me because I had half my project falling out of schedule, and I had to pull the group together to get us back in line to deliver on the November 24th goal. The first spot that we started was the headscarp. It posed the largest potential for failure. It had the highest it had the highest risk. So what we did was we started in May and we started mining. We started dozing and mining with our 4100 shovel and trucks. To the side, it kind of gives you representation of where we were at. So this was May 13th. To do some of that mining, we actually had some fill material, but then there was a large portion that was rock. And so we had to bring in an autonomous drill. We took a drill out of our production fleet, and in 3 weeks we had an autonomous drill on site operating. And you can see here, this is the first pattern. We started with a 9-hole test pattern because we were worried that a blast might set off a larger scale failure. So we started small and worked our way up. Once we got our blasting program in line, we started using our remote equipment and manned equipment. You can see that the guys in the bucket truck were actually up in the air running these remote dozers and excavators as we took the headscarp down. By September 2013, we removed almost all of the headscarp that we had to get it to an appropriate factor of safety. By the end of November, this is what we were left with. We mined over 400 feet off of the headscarp, and we're at a safe factor of safety. I talked about the guys in the bucket truck. A key learning for us was when you're running remote dozers, how you look at them and how your vision and angle on them is key. We actually had an incident where we lost a remote dozer over the top. And I'll tell you, when you lose your first remote dozer over the edge of the headscarp, when you call your boss and tell them that you lost a dozer over the edge, that's not a good feeling. this could have been a key turn for us. It could have took us either off schedule or put us right on schedule. But the key was, when I talked to my boss, he said, look, he said, you can recover the dozer, but you can't put any people or equipment at risk. Well, that was the nice part about having a bunch of remote equipment laying around. I was able to keep the people safe, and I actually was able to dig down to that dozer with my team, and we were able to pull that dozer back up to safety. We had to remove the Bingham shop that was destroyed in the failure, and it was sat right over top of a 400 vertical foot start. We had to do that with a remote excavator. We tore the shop down completely with a remote excavator. We went in it, we stripped the structure down, and then folded the structural pieces and shook it down piece by piece. This is the 6190 knob. I spoke of the knob that sat above our office buildings. This was posed one of the highest risks for us for equipment. If you actually look here, this actually went over steep, and it went over 90 degrees. It actually had an overhang to it. You had to crawl out there with the remote equipment to get that remediated. So this kind of gives a scale of some of the vertical drop that we were dealing with. So this picture was taken from one of those bucket trucks. The guys were operating that remote excavator from this vantage point, and we actually went out and we worked our way through that knob with a remote excavator with a ripper on the excavator in a bucket, and we just were slowly taking this down where we could build drill grade to get our autonomous drill out on it. Once we got that down far enough, we were able to put our autonomous drill to work. We were able to go and do our autonomous drilling and then blast it, and then we'd move in with our remote equipment to dose the knob down. This is the knob after it was completed. The E5 bench cleaning. On the side, we had over 2,000 vertical feet of bench cleaning that needed to be done. We started at the very top, and we kept working our way down bench by bench till we got to the 10% road. This is a completion picture. Once we had thrown all the material down, we had our road dumped in, and we mined it out with a 4100 shovel that was commissioned. So I spoke of having to reestablish our pit access road. The first piece was to develop a flock cut to get us down far enough to actually start dumping the road into that scarp. We also had to take care of some of the oversteeped area with that scarp as well, so we had to dozer push a little over 500,000 tons. Once that was completed, we started dumping in our 10% ramp, and it took just under 2 million tons to complete that design. We did this in almost a month, from when we started dumping in to when we completed the dumping, and it took a lot of effort between geotech and operations to ensure that our advance rate on this dump didn't go too fast, and we didn't put ourselves at risk as we dumped this in. This is a picture of us starting the dumping process. We pretty much started from the left and worked our way to the right and worked our way on over. You can see that there's some equipment out in the failure on the right-hand side. We're actually doing some foundation work to ensure that as we dump this across that area, that we wouldn't have an additional failure of our 10% access road. Later on, we identified that we needed to actually build some keys and some benches in here to actually hold the 10% as we came across dumping it in. So we actually put dozers out there and developed some benching and keying in to hold the 10% up. Once the road was dumped in from 6190, we tied in. We moved in that brand new 4100 shovel, and we started mining. And we started mining our way through. We had to throw the material that we had thrown down from the E5 bench clean sat on the old 10% road, and we moved in with the shovel and mined that out. We also took one of the shovels that we built in the lower pit, and we started mining from the bottom so that we could actually accelerate the time frame. The 10% road was dumped in and mined out by the end of October. So the next piece was uncovering E4 North. We were mining in E4 in the southern side of of this cut, where Brad talked about the 68 shovel and its record performance rate. We were tasked with actually getting the next order covered, and this is the area that we were working on. The slide had completely covered this area. There was about 9 million tons that needed to be moved by the time we were completed. To do this, we worked with excavators and dozers, mostly manned in this area. However, we found that we kind of employed some coal mining techniques where we use an excavator to assist dozers, and then we would slot dose the material away, and we use the excavators to clean the walls. We also started mining with a shovel as we got areas uncovered where we had safety benches above them, and we move in with a shovel and mine. We also had started splitting it out into multiple areas to get more equipment into the E4 area. At one point, we operated with over 30 pieces of equipment in the E4 North uncovery. So the other piece was we had to build a road back up into E4 because we had mined out our access. You can see the drills in the lower part of the slide. We had actually were mining there while we're uncovering the next part of the ore. So our access used to come up through that area that we had mined out. So we had to develop a new access. So we dumped in a fill bridge road that tied in with E4 North. And then we actually utilized the slide material that we're dozing off to develop an access road in. By the time we were done, we tied the road in. This is about the point where we started uncovering our next ore. This was in November. We had uncovered our shovel that was damaged. We'd also uncovered some drills that were damaged, and we were just finalizing our final drill grade on the bench in November. By December 2013, we were mining in the E5 cut in the next ore above, in the next waste phase above, and we were also mining in the E4 North area, starting to take that down. By January 2014, we took over 4 benches in that E4 North area. You can see the old existing road that we dumped in. We actually are 2 benches below that at this point. So I think the key to take away here is our target was November 24th. Our target was November 24th, 2013. We delivered that on November 15th, 2013. We dumped our first load of ore into the crusher with the 401 haul truck, which was one of the haul trucks we recovered out of the bottom of the pit. We also did that without injury. We did a lot of work with remote equipment, and we did a lot of risk assessments. Every one of those work streams or areas that remediated required a full plan, written plan, documentation. It required a risk assessment. It required a management of change process to be signed off by multiple parties. It required external, internal geotechnical review. And the last piece was we had to get MSHA approval to go remediate that. So this was a picture of the team on November 15th when we dumped our first load into the crusher.
So we've talked a bit about the Manefay, a lot of the different things that we did, a lot of the different lessons. Now this is the picture of the Manefay, or our east wall, on April 9th. April 10th, our world changed, and Manefay occurred. Not only did the mine change, but I think everybody at the mine changed as well that day. But with a lot of work, a lot of commitment, I think we actually surprised ourselves that we were able to get the mine back in operation. We had the next ore cut completed by the November 15th time frame. So there's been a lot of lessons for us, and we hope that we've been able to share some of those. And if you have some questions now, we'd be happy to try to answer those.
Excellent. Thanks so much, Brad. That was a really amazing presentation. I'm so glad that you guys were able to join us today and do this webinar. I do have a couple of questions that have already come in, and you and Cody can decide amongst yourselves who is the best person to answer each of the questions. So the first question is actually a two-part question, and it reads, has the mine been stable since the slide? Has there been any movement detected anywhere else in the mine?
So the mine is always moving, right? When you have a large open pit like this, every wall as you mine is actually moving. So to ask if there's any movement is not the right question. The stability is the right one. And so we have had some areas that we're monitoring. We've had some smaller slides, typical 2 or 3 bench failures that we see have had in the past, and we continue to have. And so that's gone on. We have been remediating some additional larger areas. We're doing a lot of geotechnical work right now because we look at the world differently, and we look at the possibility of larger failures that we may not have thought about in the past. And so we're going through a fairly major pit evaluation, high wall evaluation right now, and reevaluating everything based upon what we're seeing that night at the Manefay.
Wonderful. Thank you so much. The next question was submitted by attendee Tom Newman, the Chief Geologist for Holcim, I think, but I may be pronouncing that incorrectly. His question reads, can you go into some detail on the employee slope training and daily logs?
So our employee slope training is done both when they first come on site. So as part of our both MSHA and site-specific training, we go through as far as we show pictures. This is what, if you see this type of dust cloud, that's a little bit unusual. If you see rocks that are falling down, if you see a crack developing. So we go specifically through different scenarios with them of what to look for. And we also tell them how to communicate that their first response is to their direct supervisor, and if the supervisor's not available, they go into what we call production control. And if production control is not available, they also have the ability to go directly to the geotechs. So there's a process. We actually put out a map from the geotechs on a monthly basis that shows areas of concern of the pit so that our employees can be even more alert in those areas, and it has the names and numbers of people to call in case somebody should see something.
Excellent. Thanks very much, Brad. The next question reads, how will this experience affect your Cornerstone project plans?
Well, that's a good question. So somebody knows more about Kennecott than most. So right now we're continuing to mine Cornerstone. Cornerstone is part of the overall pit evaluation that we're looking at. So obviously part of this process is to review all parts of our pit, all parts of our production. Cornerstone is part of that. We're going through that process right now and evaluating that. But we're mining Cornerstone as we speak, and that process is currently going forward.
Okay, great. The next question reads, how will the 25 pieces of remote systems equipment be used after the remediation work is completed?
So the plans with 25 remote pieces, not all of it will stay. However, the autonomous drills will continue to develop the autonomous drills. We're actually working on some additions this year with planners and Scotco on the 4 drills that we have on site to address that program. The remote dozers, we're actually working on a project right now that we use remote dozers to finalize a little bit of some remediation work that we're doing. That will just provide us a little bit more ore. So that's going on. And I think our learning was you got to continue to put the remote in the people's hands. I I mean, they're a pretty quick learning curve. We put our most trained employees on them and let them go run them. And, you know, they pick them up fairly quick, but we did have some learnings that we want to ensure that our people continue to develop those skills. So anytime we get a failure, we have that option. If we have a small scale failure that we need to go review, we have that option in our hand. And that comes out in the risk assessments that we do on every one of these before we clean them up.
Great, thanks, Cody. The next question reads, can you give any indication of the cost in terms of man hours and dollars?
Yeah, this is Brad. No, we can't. So, you know, costs are not something that we're really ever allowed to talk about.
Which is certainly understandable. Let's see, the next question from Rio's pit results Q3 2013, copper tonnage was 59.1 thousand, which raised to 64.5 thousand in Q4. Do you expect ore rates to continue to rise over the next few quarters?
So our production, copper production, is really based upon grades, and our grades change throughout the pit. And so one of the things that's happened with the Manefay is we had to take, we're not able to blend as much as we have in the past, so we kind of have to take whatever grades available to us at any one point in time. So we'll see those tonnages change based upon the mining conditions. And, you know, we can't really project or predict or talk about what they'll do or what they won't do.
Okay, the next question. How did you manage to go from 50K TPD to the plus 100K TPD with the P&H 2600?
The 2800? Well, that's a great question. There was a lot of focus. We did things differently with that shovel than we'd ever done before. For instance, we would put 2 shovel operators on the shovel at all times, so that if one shovel operator was getting tired or needed to take a break, they just switched out without having to actually stop the shovel. We did other things such as the maintenance work. If the shovel went down for any period of time, more than about an hour, we considered that a major incident. And we have what's called incident command, where you have an incident commander that has basically control of the pit at that point in time. He's able to tap into any resources that he needs as far as parts, people, supplies. And so if the shovel went down long enough, relatively short period of time, an hour and a half, we would have an incident commander that was there finding a way to get that resolved as quickly as possible. We also found a lot of ways to take out all of the delays as much as possible. Everything from the way we started shift and ended shift, so that we would keep that shovel running as much as we could.
Okay, thanks so much. The questions are really flying in, so I'm just trying to weed through some that are new and give you some new questions. Some of the questions are similar. So the next question is, did you change your geotechnical design methodology? And do you have recommendations from your review team on future designs?
So we are doing additional geotechnical work that we haven't done before. We are actually using different modeling. The geotechnical slide causes are actually still under investigation. So we don't actually have all the answers yet of what caused it and all the different things that we're going to have to change in the future. But we certainly are looking at the wall in a different way than we ever have, and actually doing additional analysis of large failures that we didn't do before. So there will be a point in time when we can talk a lot more about that. And unfortunately, I can't go into all the details at this point until the investigation is complete.
And that's certainly understandable, Brad. The next question reads, what was the most effective technology used to predict the slide?
You know, we use redundant systems, and I don't think any one is the most effective. I think it's really a combination of a lot of different technologies. So certainly the different radar technologies were used, the prisms were used, and just the visual inspections, the cracks and those types of issues were all used. So I don't think you can say that there's one that's most effective. I think the point is that you have to have multiple systems to do it well.
Okay, thanks. The next question reads, what was the involvement and contribution of MSHA?
All right, this is Cody. So MSHA's involvement, when we first had this failure, they came out and they actually established a K order on the mine. So that we weren't allowed to actually go into the area within the slide, and that extended down to where we consider the potential 20 million ton failure to go. So any work that we did around there, we had to have a written plan. It had to be, we reviewed it ourselves. We did all the risk assessments, did legal review, and submitted it to MSHA. They would review that plan, and then we'd have to get together and actually have a meeting to discuss the plan and actually go through the plan in detail before they would give us approval. The other aspect is they would be out on a weekly basis for a tour to see what we were doing and ensure that we were delivering on our commitments on our plan. So altogether, we submitted over, I think we ended up submitting almost well over 15 plans to MSHA as we did the remediation work.
Okay, thanks, Cody. The next question is a two-part question, and it reads, amazing innovation in adversity, but will the 240% increase in number 68 shovel productivity impact mine planning and production elsewhere in the business?
I'll take that one. You know, we had a lot of learnings from the 68 shovel. We learned that when you put focus on equipment and things like, and really focus on the shift change and ensure that it's operating as much as possible, you can get those gains. I don't know that you'll continue to sustain the full amount that we gained, but definitely have seen it increase their shovel productivity across the board at many gains.
So this is Brad on that question as well. So the other thing to remember is those were extraordinary circumstances, and it's not just the shovels that make a mine productive. It's also the trucks. And so we were in a situation where we actually had trucks available for that shovel to keep it going. When you take a look at our entire fleet and shovels, having every shovel work at that rate is actually not feasible and probably not practical. We have to blend, we have to do a lot of different things. So at the end of the day, when we're often truck constrained instead of shovel constrained. So the idea is actually to increase the truck productivity as well as the shovel productivity.
Thanks for that, Brad. The next question reads, were there any seismic effects on neighboring communities?
So there was, there was actually a earthquake that was created by the landslides. So there are two events, one at 9:30, one at 11 o'clock. 15 minutes later, there was actually a detectable earthquake directly below the Manefay. It was detected by the University of Utah. But we've had no reports that any person was able to actually fill that event. So yes, there was a seismic event. It did not have any impact on the surrounding areas.
Okay, thank you so much. The next question reads, did the Manefay slide affect your current and future waste rock disposal areas? For example, the Keystone East Waste Rock Extension Project.
So obviously we have more material to move now than we had before. We increased the total amount of material by basically the 144 million tons, plus or minus a bit of that. So it certainly has impacted our dumps and how much dump space we need. There has not been a resolution on long-term capital that we'll spend for our dumps, so we're still reviewing that at this point in time.
Okay. And what was the overall inner ramp angle, IRA, of the wall prior to failure? What is the new IRA design for the remediated wall?
So I can't talk at all about geotechnical designs at this point until the investigations are complete. So it's not a question I can answer.
No problem on that. Kennecott mine aside, does Rio plan additional mining in the Bingham Canyon orbit and nearby Ochre Range?
So Kennecott and Rio Tinto are always looking at the resource in the area. That's part of what I think just about every mine does, and so we will continue to do that, but we don't have any specific plans that we can discuss right now.
Okay, let's see, I think we have time for just a couple more questions. The next one reads, is there any infrared video of the rock mass avalanche?
So obviously they're asking about infrared because it did happen at night. So no, we do not have an infrared video of that.
And how were the drill holes loaded after the remote drills finished the holes?
So this is Cody. I'll take that one. So when we first started, we actually developed, we did a lot of SQRAs, so we quantitative risk analysis on that. But we also established some horizontal lifelines that we would fix to points outside of the remote zone so that our people were tied off. And then once we got it down, we looked a lot at the exposure time of how long they would be out there and a lot of probabilities and things like that.
Okay, thanks, Cody. The next question reads, did you have slope stability monitoring equipment stationed above and behind the slide prior to the failure?
So not so much as far as, depends which type of equipment. So we did have drill holes, monitoring downhole with drill holes. We had extensometers on tracks behind. But the monitoring equipment as far as the radars were basically all in front of the slide, not behind it. But we did, like I said, we were monitoring the cracks with extensometers and such.
Okay, great. Thank you so much. And now I think that we have gone through all of the questions that I've received. I would like to offer both Brad and Cody an opportunity to make any closing remarks that you'd like to make.
So this is Brad. I hope that none of you have to actually go through what we went through this past year. But as far as an engineering challenge, it's probably been one of the greatest engineering challenges and operational challenges that we ever had. I think we're all just really thankful that there were no injuries, there were no fatalities, and so it really made for a challenge that people were could learn a lot about and do a lot of different things, do a lot of different innovation. But if you're in a large open pit mine, monitoring is key, and hopefully some of the things that we've learned as far as the monitoring and having multiple types of monitoring will be helpful to the rest of the industry.
So this is Cody. You know, remediating the Manefay slide was probably a once in a lifetime opportunity. I think we learned a lot about our business, and I think the people at Kennecott really pulled together to make this happen. I think another piece was the operational communication with the planning and geotech group on this. You know, we developed a lot of plans, and we actually had to work with multiple groups from groups that were bringing equipment in, groups that were ensuring we were safe, groups that were making sure that we were working on another failure, and all those plans all together, and the communication that went into that was it was phenomenal, and I think that was a key to the success of this the cleanup at Bingham.